11.6 is about finding segments in circles. So we're moving away from finding angles and arc lengths, and we're moving towards finding how long segments are. We have 3 different cases for this situation as well. And just remember that these formulas are on your note sheet. I just want you to understand what they mean. So if I have 2 chords that are intersecting, I'm going to go ahead and label the parts of my chords. These are the line segments that are created by those 2 crossing chords. The way I can find my missing lengths is I can do part times part equals part times part. And when I set this up, I just want to really make sure that my one line segment stays on one side of the equal sign and my other line segment stays on the other side of the equal sign. Another situation is that my 2 secants intersect outside of the circle, and we can label those line segments. And for this one, it's going to be the outside part times the whole line segment. So that would be A times A plus B is equal to the outside part times the whole line segment. So that would be X times X plus Y. And again, I kept one line segment on one side of the equal sign, and I kept the other line segment on the other side of the equal sign. And then the other situation is that I could have a secant line and a tangent line that intersect outside of the circle. So when that happens, one of my lines just has a tangent part. So that part we call X. And then the secant line actually has 2 parts, the part outside the circle and the part inside the circle. So it would be the outside part and the whole when I'm doing the secant line. So the formula for that would be, in symbols, the tangent part squared, and then the outside part times the whole line segment. Okay, in class I walked through example 1 and example 2, and then students worked on 3, 4, 5, and 6. So I'll walk through example 1 here. For example 1, I have 2 chords because their endpoints are on the circle and on the circumference, and so I'm going to use the chord equation. So I'm going to do 6 part times part equals part times part. Remember, I keep my line segments together, so 10 and X are on one side of the equals, and 6 and 15 are on the other side of the equals. And then when I multiply those together, I get 90 equals 10X, and then I can divide by 10. So X is equal to 9. And then students in class pointed out that there was a typo on your note sheet. We're not finding X and Y, we're only finding X. There is no Y. And then example 2, I have 2 secant lines that are intersecting outside of the circle. And so for those ones, I'm going to do outside part times whole. So 7 is the outside part, and then the whole would be 7 plus X equals 6, and then the outside part would be 6 plus 15, which is 21. If I distribute the 7, I have 49 plus 7X equals 126. And then if I subtract 49, I have 77. So X equals 11. And then it's not a bad idea to take a look at X equals 11, and does that make sense in our drawing? Does it look like that line segment could be about 11? And that does seem reasonable in our drawing. All right, thank you so much. Good luck.